All right, in math, when we have two or more objects with the same shape but different sizes, then we call these similar figures. And if two figures are similar, then their corresponding sizes are proportional. So we can use what we learned from solving proportions to solve similar figure problems. Let's try this one. So this is a bass and this is a violin, and these two figures are similar. If the total length of the bass is 72 inches, but we're looking for the length of the body, we can use the fact that the total length of a violin is 24 inches and the length of its body is 15 inches. So let's write the proportion equation. So we've got the length of the body divided by the total length. So let's put in the numbers for the violin. The violin body is 15 inches. The total length is 24 inches. On the bass, we know the total length, and we're looking for the body. And you could either multiply both sides by the least common multiple of 24 and 72, but because there are no terms, no plus or minus, we can use the shortcut called cross multiply. So 24 times x is 15 times 72. Times 72 is 1080. And then to get x by itself, we'll just divide both sides by 24. So 24 over 24 is equal to 1. 1080 divided by 24 is 45. And then we can look at the picture and see if that looks right. So 24 and 72, 15 and 45. Well, in fact, 24 times 3 is 72. So it makes sense. 15 times 3 is 45. All right, let's do another one. Oh, before we do the next one, remember that we were given units in the original problem. So you always want to include units in your answer. All right, now let's try another. All right, a building casts a shadow of 105 feet. So that's this length. While a 21-foot flagpole casts a shadow that's 15 feet. And we can use this to find the height of the building. Now, if you want to start it on your own, I would hit pause here and see what you get. All right, so let's write this as a proportion. And it doesn't matter which one you put on top. You could put the height on top or the shadow. Just so long as you do it the same in both ratios. So for the flagpole, the height is 21 feet and the shadow is 15 feet. For the building, we're looking for the height, so we'll use a variable, and the shadow is 105 feet. We have a rational equation, but there's no terms, so we can use the cross multiply shortcut. 15 times x is 21 times 105. 21 times 105 is 2,205. And then in order to get x by itself, we'll divide both sides by 15. So 15 over 15 is equal to 1. 2,205 divided by 15 is 147. And remember that we're given units with the original problem, so that's 147 feet. And you can just look at the picture and ask yourself, does that look about right? And the answer is yes. Let's try another. So here we have a 20-inch computer monitor that is proportional to a 17-inch computer monitor. On the 17-inch monitor, we have 1,050 pixels in the vertical direction and 1,680 pixels in the horizontal direction. For the 20-inch monitor, we've got 1,920 pixels in the horizontal direction. Can you find the pixels in the vertical direction? So this would be a good time to hit the pause button and try this one on your own. All right, so let's write the proportion equation. So we've got vertical pixels over horizontal pixels. Or you could do it the other way. The important thing is to be consistent. So for the smaller monitor, the vertical pixels are 1,050 and the horizontal pixels are 1,680. For our larger monitor, we're looking for the vertical pixels, so we'll use X, and the horizontal pixels are 1920. So this is a rational equation with no terms, so that means I can cross multiply. That's 1,680 times X is 1,050 times 1920. 1,050 times 1920 is 2,016,000. I want to get X by itself, so I'm going to divide both sides by 1,680. $1,680 over 1,680 is equal to 1. And 2,016,000 divided by 1,680 is 1,200. Let's look and see if it makes sense. It looks about right. And remember, we're given pixels as units, so let's include that in the answer. 1,200 pixels. All right, let's try another. All right, let's try another one like the building. All right, a building casts a shadow that is 128 feet, while a nearby flagpole casts a shadow that's 32 feet. If the height of the flagpole is 24 feet, how tall is the building? So at this point, you should definitely be able to do this one on your own. So I would hit the pause button and try it. All right, so it doesn't matter which one goes on top, the height of the object or the length of the shadow. So we'll just start that way. So let's do the flagpole first. The height is 24. The length is 32. We're looking for the height of the building. The length is 128. There's no terms, so we can use the cross multiplying shortcut. So 24 times 128 is 3,072. I want to get x by itself, so we'll divide both sides by 32. Thirty-two divided by 32 is equal to 1. 3,072 divided by 32 is 96. And all of our units are feet, so that's 96 feet. And then once again, we can look and say, does that sound about right? All right. All right, let's try one with a violin and a cello, which are proportional. So if the body of a violin is 15 inches and the total length is 24 inches, if we know that the total length of a cello is 48 inches, how long is the body? So by now you should definitely be able to do this on your own. So I would hit the pause button and try it. All right, so we could have the body over the total length. So for the violin, the body is 15 inches. The total length is 24 inches. And then for the cello, we're looking for the body. They use B, so let's use B over the total length. There's no term, so we can use the cross multiply shortcut. So 24B is 15 times 48, which is 720. And then we want to get B by itself, so we'll divide both sides by 24. Twenty-four divided by 24 is equal to 1. 720 divided by 24 is 30. Remember, we were given units with the original problem, so all of these are inches. That means our answer is 30 inches. And then let's look and see if it makes sense. Well, 24 times 2 is 40, so it makes sense that this side is twice 15, or 30. And there you have it.